All right, so today we are going to be covering section 3.2, which is working with evaluating algebraic expressions. Now, it should be seen by the title of this section that we already have a buzzword in it, which is going to be an indicator of what we're going to be doing for a good chunk of this particular section. Evaluating. It should be the buzzword to you of I'm going to be using PEMDAS and simplifying things down. Evaluating, simplifying, kind of going back and forth there. So the way that this section is going to work is we're going to be given an expression of some way, shape, or form. We can already see a couple or quite a few of these down here. And we're going to be given some values and we're told to evaluate it where if some variable has this value, some variable has another value, anything like that. So our process that we're going to go through with this is a pretty straightforward one. Again, I think the big kicker with this section, as with so many in the past, is making sure you are doing the setup process correctly. Because a big portion, at least two of our three major steps with this, are going to come from making sure that you have everything written down and written in and substituted correctly. If you don't do that correctly, this entire problem falls apart and we're going to lose points on that, which you don't want to do. So first things first, I highly recommend above all else when you're doing these problems, actually write out your work on a piece of paper. Some people like to use whiteboards for this. That's fine. Do whatever works best for you, but actually write out what you're doing over anything else. So first step, write the original expression and then somewhere nearby what each variable is going to represent as a value. And the big kicker with this is, as we're seeing with some of the examples, we're going to be given some stuff. We're going to be told what A is, what's B, what's X or Y or Z or anything like that. Have that written down and nearby so you can take a look at that accordingly and have that ready to go for yourself for the rest of the process. Plus, it's another way of keeping your work organized. So once we've had all that written down, we're going to substitute each variable from the original equation with the designated value. When you are doing this, make sure you are including the signs of whatever we have been given. Write everything inside of parentheses. A lot of people do not do this, and suddenly we went from having things multiplying together to now they're adding together or subtracting together. And if we don't do that, we have fundamentally changed the entire problem that we are working with, and we're going to lose points that way. So when you are doing step 2, this substitution step, always, always, always substitute things in inside of parentheses. Doesn't matter if the number is positive, doesn't matter if the number is negative, always substitute in inside of parentheses. I cannot emphasize that step enough. And we'll see, I'll go through a couple examples where if you don't do that, we're going to get completely different answers and lose points at that point in time. We don't want to do that. So once we have everything written out, once we have everything substituted in correctly, including the parentheses with that, then we're just going to evaluate and simplify what we have left over. And all we're using is PEMDAS for that. So even if you're looking ahead at some of these going, well, this thing looks really complicated, there's a bunch of stuff going on here, we're just using PEMDAS. It's our step-by-step guide. And if you're also looking at these going, oh man, that is a lot going on there, I don't know if I'm going to be able to do this, then that should be your cue, first and foremost, to not rush your process, to take this very, very slow and very, very methodically while you are going through this for the first time. There's nothing wrong with doing that. Okay? A lot of people think I need to be able to substitute this in and solve it in 2 lines of work. No. If you can do that, great, but I am not expecting you to be able to do that from just learning this today. So if it takes you 3, 4, 5, 10 lines of work to get some of these things fully simplified, great, that's fine. Nothing wrong with that. But make sure you are going through and being very organized and very systematic as you are simplifying and evaluating these expressions. Okay. So these are the examples that we have here. I don't believe there's any more down below. No, there aren't. So from here, I am going to jump us over to our whiteboard. Come on, I'm trying to get this to work. Jump over here. Okay, so when I'm referencing examples 1, 2, 3, 4, and so on, these are the ones, the front end, what I'm looking at. Okay, so our first example that we have, again, with all of these, we are told to evaluate. So we are going to be using PEMDAS at some point in time with these. Okay, so our first problem that we have been given, we have a squared minus 3ab minus 4b squared. And we have been told where a is equal to -3, b is equal to -2. So for me, I like having, there's my expression, and then I'll put off to the side here, a equals -3, and b equals -2. Okay. So following our first step, write the original expression, and then somewhere nearby what each of the variables values will be. So we've got our expression right over here. We've got our variables over here. So we're good to go on that front. Now our second step, and again, this is the one where it seems pretty straightforward, and I think of, okay, I'm just plugging in each of these values in for A and B in our problem. That doesn't seem too difficult, and really it shouldn't be. But again, the thing that people do not do is they do not substitute these in inside of parentheses, and it costs people a lot of points if you do not do that. So writing and substituting that in, wherever an A shows up, I'm going to substitute that with -3. So our first part that we have here, let's make that 3 a bit better. There we go. And then wherever a B shows up in this equation, this expression, I'm going to substitute in a -2. And again, when you are doing this, make sure you're doing all of that inside of parentheses. So that a squared at the very front, very beginning of this thing, this a squared, that means if a is -3, that means all of -3 is being squared. Minus 3 times ab. Well, a is -3, keep it inside parentheses. B is -2, keep it inside of parentheses. Minus 4 times b to the second power. B is -2, so all of -2 is being raised to the second power. Okay? So parentheses are absolutely vital when you are going through and doing this substitution process. Because I'll show you guys here now, before I go solve this thing any further, how this is going to look fundamentally different as an entire problem if you do not do that. So this is the step that you don't want to do. Let's say instead we don't use parentheses. Well, suddenly now, I have -3 squared versus the quantity of -3 squared. Fundamentally different problem. If I don't print parentheses in the middle part here, I end up having -3 minus 3 minus 2. And then in the last part, if I don't put parentheses in, I end up getting -4 minus 2 to the second power. I have a fundamentally different problem altogether. And I'm going to get a wrong answer if I do that. So again, I cannot emphasize it enough. Make sure when you are doing the second step and you are substituting values in, always substitute values in inside of parentheses. If it's positive, negative, doesn't matter. Always put those parentheses in. And again, I'm going to sound like I'm going to be saying this repeatedly throughout this entire lecture, but it's vital. You don't do that, you're going to lose points. You're going to get the problem wrong and all of that. So from here, now we have everything substituted in. Our third step in the process, we're going to evaluate and simplify the resulting expression. We're using PEMDAS. So I'm just going to put PEMDAS off to the side here. So first things first, working with parentheses. Can I do anything inside the set of parentheses that I have? And no, I can't. I'm then moving on. If I can't do anything with that, then cool, done there. So I'm moving on to exponents. Do I have any exponents? Yeah, I have two things being raised to the second power. I've got this one here, and I've got this one here. So I'm going to go through, and I am going to be evaluating each of these using our exponent. So I have -3 to the second power. It's going to give me 9. I'm not doing anything else in this process. I'm just working with exponents right now. And then I have -2 to the second power. -2 to the second power is going to give me 4. You might be wondering, okay, so why in this instance do I keep the parentheses, and why in this instance do I get rid of them after I've used the exponent? And the reason we can get rid of it in our first scenario with the 9 is I have nothing else going on there. I have nothing else being multiplied by that, so I can just leave that there as a 9 at the very end. If you want to put parentheses around it, you can, but in that instance, we don't need to have it there. In the instance at the back end, I still have things being multiplied together. So I need to keep that parenthesis around so I can show that the 4 and the 4, well, I guess the -4 and 4 are still multiplying. So from here, we've gotten rid of all of our exponents. We have multiplication and division going on. So all I'm going to do is multiply things together. So I'm going to multiply these two together and these two together. -3 times -3, it's going to give me a +9. And then a -4 times 4, it's going to give me a -16. I still have multiplication going on here. I'm just going to keep working with that. 9, a +9 times -2, -18. Get to that there. Get rid of that. So from here, we've gotten rid of all of our multiplication and division. We have addition, subtraction going on. So we have 9 minus 18. That's going to give us a -9 minus 16. So we're just working with that. And then one more time, we've got 9 minus 16. And that is going to give us a -25 for our final answer there. Okay. So again, a big portion of this is just doing PEMDAS. If we're comparing all of our steps that we have here, we have step 1, step 2, and then all of this down here is step 3. But all of step 3 hinges on making sure that we have done step 2 properly. If we don't do this step that we have right here correctly, then everything with the rest of it's going to fall apart. Okay, let's move on to our second example here, because I do want to give us a good healthy amount of these, because again, the process is fairly straightforward. It's just making sure we're doing it properly the entire time. So we're working with xy plus yz minus xz. And we are told that x is 5, y is -1, and z is 2. Okay. So that's our first step. Write out the original expression, and then somewhere nearby we're putting each of the variables with their values next to it. Okay. Step 2, substitute each variable from the original equation with the designated value. So wherever I see an x, I'm going to put in -5. Wherever I see a y, I'm putting in -1. And wherever I see a z, I'm putting in 2. So all I'm doing is just rewriting. And again, when you are doing this, use parentheses. Cannot emphasize that enough. You guys are hopefully going to be sick of me saying that by the end of this lecture. And if that is the case, I've done my job. Just I'm telling myself that. So again, when you're going through and substituting this in, okay, all of my x's should be 5s. Okay, so I have an x here and here. There's a 5, there's a 5. Okay, good. Check my y's. Got a y here and a y here. That should be -1 and -1. Okay, good there. Check the z's. Got a z here and here. That's a 2 and that's a 2. Okay, I'm good. I have everything substituted in correctly. Now I can go through and I can just use PEMDAS to solve the rest of this out. So again, just working with our parentheses, I can't simplify anything inside the sets of parentheses that I have there. So I'm moving on to exponents, don't have any exponents. I have multiplication, so I'm going to multiply things together. I'm going to get 5 times -1, it's going to give me a -5. I have a -1 times 2, and that's going to give me a -2. And a -5 times 2 is going to give me a -10. So I'm done with parentheses, done with exponents. I have no more multiplication, division, and I'm just going to add everything together. So I'm just going to add the first two parts. That's going to give me a -7 minus 10. And then add those. That's going to be a -17. And then I'm done. Okay. Not much else to do there with that. Move on to our third example that we have here. Dividing line here to try and keep myself a bit organized if I can help it. So our third expression that we've been given. So we have the absolute value of 2x, the second power, minus 3 times the absolute value of y plus xy. And then we are told that our x value is equal to -6, and our y value is equal to 8. Okay. So just like we've done with our previous examples, we've got everything written out for ourselves. Now we're going to substitute values in. And what am I going to say? How should we substitute these things in? Inside of parentheses. The big takeaway from this section, I think, over anything else. -6 and then 8. Okay, so again, take a quick second to make sure all of the x's are substituted with -6 and all of the y's are substituted with 8s, which it looks like they are. So we're good to go on that front. And now, again, we're just applying PEMDAS and our order of operations with these. So again, looking at our sets of parentheses, remember that the absolute value is considered a set of parentheses, so we do want to work inside those first. So because of that, I am going to work with our first set of absolute values first. So going inside of there, I have multiplication going on. So I'm going to do 2 times -6. It's going to give me -12. Minus 3 times the absolute value of, I just have 8 in there. It started off as a positive in that middle term, so I can just take those parentheses out at this next point in time, since I don't, I know what the value is and I don't need to have it multiplied or divide or anything by anything else, so I can leave that there. So now from here, I'm still not done with my sets of parentheses. Looking at my first set, the absolute value of -12, I can now apply the absolute value property because the only thing left inside the absolute value value signs is a single value. There are no other operations going on inside there. So when I do that, what is the absolute value of negative 12? It's going to be a positive 12. The exponent on the outside is just going to stay there. We can do the same thing with this absolute value of 8. The absolute value of 8 is just going to be 8. So we've got all that there. So our parentheses, done. Moving on to exponents, we do have exponents showing up in here, so I'm just going to work with those, or that one, I should say. I have 12 to the second power, that's going to give me 144. Got that there. Exponents are done. Working with multiplication or division, I'm going to multiply these together. Come on, start writing. There we go. So I have negative 3 times 8. That's going to give me negative 24. And then I have a negative 6 times 8. That's going to give me a negative 48. We've got some double signs showing up here. If you wanted to take care of those there or later on, you can do that also. So we have multiplication or division done. Addition, subtraction, adding things together. I don't know what those numbers are off the top of my head, so I'm going to apply calculator off screen. You're welcome to do the same thing if you're solving these things out. 144 minus 24, that's going to give me 120 minus 48, 120, there we go. And then 120 minus 48, it's going to give me 72. There's 7. And there's our answer. Okay. So again, a big portion of this is just working with using PEMDAS in our order of operations, taking it slow and steady as we're going through and doing that. So I'm going to jump ahead here. I'm looking at the examples that we have, and I want to go through a couple that have, that have some fractions showing up. So we'll go through, I think the rest of these do. Okay, so we'll move on to number 4. Again, just for the sake of seeing a lot of examples with this. So you guys have a good idea of what you're going to be looking at or how to work with these on the homework or anything else beyond that. So again, we're just writing out our original expression that we have been given. And I think you guys have already seen me earlier on in this quarter mess up the original expression when you're writing it out a couple times. So don't make my mistake of being really fast and speeding through it. Just take your time. Write things out accordingly for yourself as necessary. Okay, so let's see. We've got 4r minus 2r squared w plus w squared. Okay, cool. I'm going to move this w to be a bit closer in here. Emphasize the multiplication a bit more. Okay, got our equation written out. And now we're just substituting values in. Again, we're substituting values in inside of parentheses. Yeah, move this up here a little bit, blocking some of my view. Oops. So we have that there. So there's our numerator. And then our denominator. Oh, I forgot the squared in there. It's kind of important. By kind of, I mean very. Okay, so does everything line up? The R's are all -4s, the W's are all 3s, all the signs and everything are written in correctly otherwise. Looks good. All right, and then we're just simplifying. So as we've gone through and worked with simplifying in the past, when we have a fraction, we kind of split this thing apart into the numerator and the denominator part and work with each of those separately, or we can do all of this as a single fraction. And I'm going to elect to separate this into the numerator and just work with that first and foremost. And then I'll do the denominator and we'll go from there. Just my personal preference on how to organize it. You can use the other method if you'd like to, the other way of organizing it if you'd like to. Nothing wrong with that, just organizational preferences or anything else. So applying PEMDAS to that, I'm going to erase this and we'll just bring it back over here with our numerator. Oops. Go. Okay, so working with our sets of parentheses, well, nothing inside there can be done. So I am done with that. Moving with exponents. I have exponents here and here, so I'm working with that first. Everything else is staying as it is. I have -4 to the second power. That's going to give me a +16. Then 3 to the second power is going to give me 9. My exponents are done. Moving on to multiplication division. I have 4 times -4. That's going to give me a -16. So working with that there, I'll work with the first two here. I have -2 times 16. That's going to be a -32. Still have that 3. And I have more multiplication going on. I can multiply these two things together. Let's see, -32 times 3. I believe that's going to give me -96. And again, apply your calculator to these calculations as necessary. But I'm now done with multiplication, division, addition, subtraction. We can actually enter all of this into our calculator at once. So I'm just going to do that. Again, try and save us a couple steps here on some of these, or at least skip ahead a little bit so we can get through more examples. So we get 103. That is our numerator. So now we need to work with our denominator, which looks like it's not going to be nearly as in-depth, but we'll work with it all the same here. Done with that. So we have, for our denominator, label this. So with our denominator, we have a -4 minus 3. Oops. So work with parentheses, got nothing I can do with that. So done there, no exponents. I have multiplication or division happening though. Got double signs showing up. So -4, a negative and a negative makes a positive, minus a 3, it's going to give me 1. So I'm done with that, done with that. So now we have our denominator, we have our numerator. Here, I'm going to bring these together. So I have -103 over 1, and that simplifies down to just being -103. We have our answer there. I'm going to zoom us out here so we can get this entire problem on screen, or at least most of it. There we go, number 4. Okay. And again, the way that you want to go through and organize how you set this thing up and separating the numerator and denominator, solving them each and then bringing them together. It's your call. It's personal preference on how you want to organize your work on that front. Okay. Now I am looking at our time, and I do want to, let's see, I'm going to jump ahead to one of our other problems. So I'm going to jump ahead to number, and we'll go to number 6. So I'm going to move us off to the side over here, and we'll go into number 6. Okay. Just for the sake of seeing some other examples with more fractions showing up, because again, fractions are not going away. So even though we've got fractions in the problem, which is fine, we are still setting everything up the exact same way we did with our previous problems. So we've got that there. We've been told A is equal to 3. Ugh, stupid. A is equal to 3, and B is equal to -2. At least I think that's -2. I'm just seeing B minus 2. I wrote that in wrong. We'll go with B is equal to -2, because I'm pretty sure that's what I meant by that. So again, all we're doing from here, we're just substituting everything in, say it with me, inside of parentheses. I'm going to tell myself that everyone said that, because it's not really much of a mystery what I mean when I'm saying that anymore. Just I'm hoping it isn't. And again, I'm using the color coding with this to try and make it stand out a bit more, but you guys in your work, I don't think are going to have it written out with this much color in there. Maybe I'm wrong. Maybe you're using colored pens or something like that. I know some people have in the past, and it's useful for them. Okay, so I have two fractions. They're subtracting together, and how the heck do we work with this thing? Well, this is the instance, again, we're using PEMDAS. That's our guide, how we're going to go through this thing. And if your other thought is, well, I don't know how to start this thing because I don't want to do all of it at once, well, good. You do not want to do all of it at once because that's difficult. So let's work with PEMDAS and our first fraction, if nothing else. So in this instance, because it doesn't look like we're going to be doing too many operations, I'm going to leave everything as a single fraction. So I'm looking at the numerator of the first fraction that we have here. I can't do anything with parentheses. I can't do anything with exponents. I can multiply some things together. I have a -2 times a -2. It's going to give me a +4. Got that there. Looking at the second fraction, same thing, working with PEMDAS. Looking at the numerator, I have multiplication. I have 9 plus -2. Positive and a negative makes a negative. And then down below, we still have a -2 there. So continuing to simplify the numerator of each of these fractions, I get 7/3 minus 7/2. So now from here, looking at this and saying, okay, well, I have double signs showing up again. I have a minus and a minus here. I want to eliminate those and get rid of those signs altogether because I don't like double signs. So a negative and a negative, separate this out a bit here. A negative and a negative make a positive. So I'm just going to work with those signs first. So I have 7/3 plus 7/2. Now I don't have to worry about, am I adding a negative? Am I subtracting a negative? We just got one sign. We're just adding. And now, here's the part where, do we remember how to add fractions together? And if we do, think to yourself here, how do I add fractions together? What is the absolute requirement that I need to have? I cannot do any addition and subtraction without it. I need to make sure that the fractions both have a common denominator. More specifically, we want to find the lowest common denominator, so we don't have to work with really large, big, gross numbers. So what is the lowest common denominator for these two fractions? It is going to be 6. So we need to scale each of these things to have a denominator of 6. So I'd say, what can I multiply the first fraction by? So the denominator will be 6. Well, I want to make an equivalent fraction. So 3 times what gives me 6? Well, 2. To keep this thing equivalent, I need to multiply the denominator and the numerator by the exact same thing for that fraction. I am multiplying it by 1 technically, because 2 over 2 is just 1. For the other one, the other fraction that we have, then multiply it by 3 over 3. Again, that's essentially 1. And when I do that and multiply those together, I am getting, there's my numbers here, that's going to give me 14 over 6 plus 21 over 6. And now at this point in time, the denominators are the same. I can add the numerators together. 14 plus 21, it's going to give me, what's that, 35? Yeah. 35 over 6. And then we have our single fraction answer. Always, always, always ask yourself when I have a fraction answer, can I reduce this fraction down at all? And it turns out with this one, we cannot. And I'll also emphasize this. Leave your answer as an improper fraction. This is a perfectly acceptable answer to write in on a test. A lot of people want to write this thing into a mixed number, which I think is going to be like 5 and 5, 6 or something like that. Don't do that. Unless the problem explicitly says write your final answer as a mixed number, I would highly recommend do not do mixed numbers. Improper fractions are perfectly acceptable. We like them a lot. They're really nice to work with compared to mixed numbers, a lot of these operations also. Okay. So there are more examples from this that we could go through, but I am looking at our time, and I am going to end it here for the lecture today. If you do have other questions, though, we can hold on to those here for a quick minute. I'll end the recording and we will go through those.